I asked you to do one of 6 or 9, was it?
Mm-hmm. Yeah.
And then 10 6. So what we'll do, we'll have a look at 6. Put your hand up if you did 6. Okay. Put your hand up if you did 9. You did both. Awesome. 2. Well done. Well, let's check. So, would anyone like to talk us through them? Okay. Question 6.
So first I noticed that they give you what y equals,
Yeah.
so I wrote it into the right
So I'm going to replace
that into the y.
Yeah.
So I did x squared plus, in bracket, 3 subtract 2x to the power of 2 equals 26. And then I wrote it so it shows you both brackets, plus, and then I did 3x here. And then equals 26. And then I expanded those brackets, so I got x squared plus 9 plus 4x squared subtract 6x.
Sorry, x squared plus 9
Plus 4x squared.
plus 4. Okay, yeah. Not in the order I was looking at.
Subtract 6x.
Subtract 6x.
Isn't I wrong?
Or am I No, you're right.
So you might. So is this right? And then minus another 6x.
Equals 26.
She's right. Okay, you're right.
And
Yeah.
then I just found.
So x squared and 4x squared is 5x squared
Yeah. And then
minus 12x.
plus 9. And then I
don't think it's
and then I
6x.
subtracted
It is.
over 26. And I got 5x squared minus subtract 12x.
Oh, yeah, you're right.
Plus 9 subtract 26, and that equals negative 17 equals 0.
Okay, stop there. Breathe.
Yep.
Okay. Do we all agree? Is everyone clear on where everything's come from at the moment?
Yeah.
Wait, where'd you put the 20? Oh, God.
So I've subtracted the 26.
Where I went wrong makes sense now.
Where did you go wrong?
I didn't do 4x squared, I just did 4x, so I couldn't add the 4x and the x squared together because they were different,
Okay.
because I did it wrong.
Do you understand why it's
Yeah.
4x squared?
If you were doing this on a test, and say you made a small mistake in the very beginning, but you did all the rest of the working out, but you still got the wrong number, would you get a mark?
Let me just check. So we've got 6 marks for this. So
say we did what Ella did and missed an x squared, would we still get the right method for the other part?
you would lose a big chunk for a mistake like that. But it depends. So for instance, there would be lots of method marks for expanding the squared. Well, there will be a mark for the substitution. Yeah? So just realising to put that in there, I would say, I'm guessing based on experience, but there'll be a mark for doing the correct substitution. Right? Then there would be a mark for doing a correct expansion and collection. Okay? So obviously, if you do something wrong with the expansion and collection, you would lose that mark for doing that. Okay? Then it depends, because if you then ended up with a quadratic that was incorrect, but you then went and did the next bit correctly with that, you could still pick up some marks. If, however, you ended up with something that was not a quadratic anymore, you're not going to get any of the rest of the marks. It's just too far away. So it does depend. Yeah. So anyway, should we carry on then? So we've got, it might even be a third mark for writing equals 0, because there are 6 marks. So we're getting it to equal 0. What do we do now?
Put it in the little.
Layla, carry on.
5 times negative 17, which equals
85.
I know. Negative 85.
Okay.
And then I was like, what works? And then I was like, negative 17 times 5 equals 85, but it also equals negative 12.
So negative 17, add 5 makes the minus 12. Okay.
So I did 5x squared, subtract 17x.
Okay, see, I would have just done it. It doesn't matter, but I would have put the plus 5x next to the 5. But because you can see how,
Oh, yeah.
if I did the plus 5x and then the minus 17x, then the minus 17, you can see how the numbers go together, but it doesn't matter. I'll carry on with what you're saying.
Okay.
So we did minus 17 and then plus 5.
Yeah, and then I split the middle term, so I split, you know what I split, yeah. And then I did x, so like I put them back into the bracket, so I did x bracket 5x subtract 17 bracket, and then plus 1 bracket 5x subtract 17, and then I did equals 0.
Still equals 0, yeah.
And then I crossed out one at the 5x 17, and then I
So we've
put,
got x plus 1.
yeah, and then I did 5x subtract 17. And then to figure out the zeros, I did 0, the x on the left side, yeah, x equals negative 1. And then I did x equals 17 over 5.
Okay?
And then to find y,
Good.
I did like y1, because there's like 2 different y's. Does that make sense?
Yeah, okay, so I've got x1 there, x2 there.
Yeah.
I'm probably going to use this one, shall we?
Yeah, so I did
Y equals 3 minus 2x.
And then I did y equals 3 subtract 2 bracket negative 1. And then y equals 5.
Okay, so y equals 5 for that one.
Yeah, and then I did the same thing, but in replacement of negative 1, I did 17 over 5.
So y equals 3 minus 2 times 17 over 5.
And that equals negative 19 over 5. So
how we do that? So I've got 3 minus 2 times 17 is 34. So if I was going to do this without a calculator, for instance.
3.4.
3 over 1.
Okay, 3 over 1, but I want it over 5, really.
So then you do 3 times 5.
So it would be 3 is 15 over 5 minus 34 over 5.
Yeah.
Does that make sense?
does that equal negative 19 over 5?
It does equal
It's
negative 19 over
I
5.
also wrote it as negative 3.8 in case it
Yeah.
wasn't
So
a
that's
decimal.
minus
Yeah.
3 and 4/5. And if we know that 4/5 is 1/5 is 0.2, 4/5 would be 0.8. So that would be negative 3.8.
I did everything right, I just got the wrong number.
Because forgot to
No,
split the
because
middle.
I did the same thing as Ella did.
No, because what happened is
Oh,
I
okay.
removed the 26 and I got stuck. I was like,
Yeah.
what do I do now?
Oh yeah, I didn't do that.
Is there an alternative method to splitting the middle, sir?
Can't you put it?
Yes. Once you get to the quadratic of 5x squared minus 12x minus 17 equals
Yeah.
0, you could use the formula to find x.
Yes, we could solve using the formula in this case, definitely. You could also use your calculator to solve that. We're going to have some practice with that. But yeah, lots of different ways at that point, right, to do it. So everyone that did it, you either got it right or you know where a mistake happened. Are you happy with that? Right, can I ask you, if you made a mistake and you know where it is, could you highlight it for me? Big, clear, bold, well, not for me, for you. And write down what that mistake was. So when you are reviewing it, you don't look back and go, oh, where did I go wrong? Yeah.
Do you prefer to put the positive in the front?
What do you mean?
So 5x in the front and then subtract.
It wasn't to do with the positive. It doesn't matter at all. So for instance, if I had done what I would have done, so I would have had here 5x squared plus 5x and then minus 17 might actually be a bit harder, to be honest. So I would have had here 5x and then it would be x plus 1 and then it would
But
be
you still get the same.
minus 17 x plus 1. So I would get exactly the same thing anyway, just go the other way round. Now actually, looking at it now, this was probably a bit harder because I've got minus minus where you had very clearly plus in the middle. So actually your way might have been slightly less tricky, potentially. Okay, so the next one then,
9.
Gabriella, would you like to talk us through 9? That's right. Let's have a go. Let's try and find where the mistake was, if there was a mistake.
So the same thing that y is like it equals y.
Yeah.
Is x squared plus bracket 10 equals 2x bracket 3x squared. Equals 30. And then x squared plus the double brackets. Equals 20 and then expanding it. So x squared plus 20 plus 4x squared.
10 times 10 is
100.
Oh shoot.
100.
It's okay.
That's right.
Okay.
Should we carry on? So we've still got the plus 4x squared again.
I keep her.
And then we've got, we've got the minus 20x and the minus 20x. Yeah?
Equals. And then it would be 5x squared equals 40x.
So it's a 5x squared, so that's that one and that one. Then it's take 40x, it's that one and that one.
Plus
Then
80.
plus 100 equals 20. So if we minus the 20, we get 5x squared minus 40x plus 80 equals 0. Is there any way of simplifying this one before we go any further? Ella?
No, never mind. I did.
Yeah.
Ella? Ali?
Divide by 5.
Divide by 5. So I could have x squared minus
If you divide
You did it last time. You did it.
x squared minus
16.
18.
8x
8.
8.
And then
What?
16.
and then
5
16.
times 8.
5 times 8 is 40.
Oh, no, sorry. I was trying to figure out what 5 times, what is it, 8?
Okay. So I've just made it a bit simpler, that's all. But we end up with same idea at the end. It's just now, it's probably a little bit easier to factorise this one. Why are you coming in?
Because I went straight to the library.
So you're late.
No, I know.
Hurry up, go. I'm recording. So this one might be a bit easier to factorise now, would it? So 16, now I don't have the number in front of the x squared. So 16, numbers that multiply to make 16 make 8. So that's minus 4 and minus 4. This one is actually therefore an example of a
Perfect square.
perfect square. Good. So I've got x minus 4 squared.
Why would it be mine?
Because it adds to make.
But why not just 4?
Because
Oh, because it's negative 8. Sorry.
Yeah. All right. So we got x plus.
Negative and a negative
Yeah, I
is
know.
positive.
I really looked at this. I was like, wait, it's minus.
But
Yeah.
if you're adding them
No,
together,
but it's
then it's.
negative.
But when you're adding them, Layla, it's a.
What she said. Okay, so we've got actually how many solutions to this one?
1.
1. So we've actually only got x equals 4 in this case. All right. So we only have to find
Why?
1y.
Wait, sorry, how did you get x equals 4? Is that like I get that it says x minus 4?
100.
Oh,
Because x minus 4, it has to equal 0, doesn't it?
yeah. I think it's just.
So then we've got, well, y equals 10 minus 2x. So therefore y equals 10 minus 2 times 4, so it's y equals 2. Now, my question, go on.
When you found out what x was, when you did the splitting of the middle term,
Yeah,
where did the minus 8x go in it?
what minus 8x?
Oh, they split it.
No, there's no minus 8x. I had
Well, oh no, down there. There.
here.
They split it.
Yeah.
No, there's no splitting happening. When you're saying splitting the middle term.
Yeah.
So at which point, so I've expanded the brackets, collected, I've got 5x squared minus 40x plus 100. Alright? What I then did was, instead of having to split the middle term because I've got 5 on the front, we divided through by 5 to give me one that I can just factorise. I don't need to split the middle term. Because we only tend to split the middle term when we've got something in front of the x squared. We've got a coefficient of x squared. So there was no need to do it. We just needed to know things that multiplied to make 16 and add to make minus 8. So it's an important thing there, girls, is don't forget the previous stuff when we move on to something else. So we only went on to splitting the middle term because we ended up with a slightly more difficult question, right? Don't try and overdo things. So, for instance, we learnt the formula to solve ones that can't be factorised. So we can always use the formula, just like I can split the middle term there if I want to, can't I? In fact, we kind of are by doing the minus 4. So it is x squared minus 4x minus another 4x plus 16. We just don't need to worry about it, yeah? Make sense? So don't forget the stuff you've done before. Now, here's a thing for you. Is it possible for there only to be one solution? What's it going to look like in terms of graphs?
If they'll be
linear.
the curve will just
Okay. So we've got, do you know what that is?
no.
X squared plus y squared equals 20. We have done it. Hey? It's not what I'm thinking. No, x squared plus y squared is not perfect square, right? It gives you a certain shape of graph.
Oh, it's a linear.
Circle, well done. Do you remember it? It will be x squared plus y squared. The radius of the circle will be the square root of 20. Because do you remember, not that you need to, but a circle is x squared plus y squared equals r squared. Alright? So is it possible, I think you've already said the answer, for if we have a graph, so here's my graph, let's say I have this circle, alright? Is it possible for a straight line with a negative gradient to only touch the circle once?
No.
It is, isn't it? Because what I think about was, if I draw it across, it obviously is always going to hit twice. However, what if I do it, no, I've drawn it that way because it's a negative gradient, so it would be something like that, yeah? Where it only touches in one place. Or it could be down here, like that. What are those lines called? Anyone remember? They are parallel, but in relation to the circle. Tangents, yeah. So if I've got a line touching a curve at one point, just one, and not crossing it, it's called a tangent. Alright? Alright, so 10C.
This one was not very nice.
Not nice.
I know 16 subtract.
Look at that.
No, what I did, does that make a positive?
Since what I did is I split
16.
them. Negative.
Subtract negative 20. Do that. Two negatives make a positive, so you
I don't want you to say two negatives make a positive. If I subtract a negative number,
From a negative.
I add the number. So, for instance, minus 20 subtract negative 2 does not become positive 22.
No, if the
It's still negative
next to each
18.
other. So like 16 subtract negative 20 is
So
positive, right?
what I'm getting is, what you're saying is 20 subtract negative 16. You're asking me, is it a positive? And the answer is, yes, the answer is positive because this becomes a plus, right? But I don't want you to always think if you subtract a negative, the answer is positive. Because if I said negative 20 subtract negative 16,
That's negative 20 plus 6.
which would be negative 4. So the answer is negative, yes, this is important. Right, okay. This one then, so this is obviously a challenge based on the stuff that you've been doing before, but it's a hard one. Yeah? Do you want to have a go?
The first thing you do is because it's a negative power, you flip the fraction. So you have the reciprocal.
Okay, so the negative there, the negative on that power means if it's a fraction inside the brackets, this is not what we're doing, the two of you. Hence you'll have troubles again, yes? I want to discuss jobs coming with my form group. And Nadiri, she did a very good job. Right, so the negative means anything inside those brackets, yes, you find the reciprocal of it. So the first step can be writing it as 8x to the power of 6, y to the power of 8, over y to the power of 5, but now it's only to the power of a third. Still a third. Only the negative did that.
And then
Brent, do you want to say something?
You know how you, when you have like the fraction power to the left, do a square root?
Right. It's not a square root, it's a cube root. But I would say I wouldn't do that yet. Because what you have to do is apply this power to all the other parts.
Oh my, I did not do this right.
So we would have 8 to the power of a third times x to the power of 6 to the power of a third times y to the power of 8 to the power of a third all over y to the power of 5 to the power of a third. Okay. Now I could have actually done something else before I did that.
Can you simplify it?
In what way?
Cancel the y.
Okay, so actually, before I even did this, do you notice how the y's, I've got 8 and a 5, what could I do to simplify that first? So I can subtract 8, subtract 5. So actually, on this level, instead of having the 8, this would become, my computer's going slow, this would become a 3. And actually then the denominator is all gone. Yeah? So my 8, my 8 and my 5, because it's y's, I can do 8, so that would be y is 8, y to the power of 8 minus 5 is y to the power of 3. So then that then is in there, isn't it? So we have no longer got a denominator, which is quite nice. Alright, but the third still applies. Now this is why I said I wouldn't turn it into a cube root yet, because actually I don't want it for a cube root there or there, but for the 8 it is worth doing. So I can do the cube root of 8, which is
2.
2. What are you saying now? You're just resting? Okay. And then how do I deal with x to the power of 6 to the power of a third? Alright, now you've got your hand up straight to this time.
I don't know if I did it right, but don't you make it like x plus 6 over 1? And then you could like make it 6 over 3.
That's what I did.
So it's 6 times a third, yeah? We multiply them. So 6 over 3 is 2. So I've got x to the power of 6 times a third is x to the power of 2.
It's like 6 over 1.
Yeah, if you want to do it 6 over 1, but I just think 6 thirds. Yeah, rather than having to put it over 1 and do that, 6 times a third is 6 thirds, which is 2. And then I've got y to the power of 3 times a third, which is y to the power of 1. So my final answer is 2x squared y.
I got the 2.
Yeah.
I don't know how he is very
Found this one, yeah?
Yeah.
Still not,
You
okay.
have to do that,
It's hard to write questions.
Mr. Pons, what does that say next to the x? X 6 over, I can't read it, sorry.
6 over 1 times a third.
Oh, thank you.
Okay?
I'll get that.
How many got that right?
Did anyone?
Okay.
I like put
Again,
6 to the power of minus 1.667.
yeah, so I would say make yourself a note, everyone, make yourself a note on this. Do not convert anything to decimals. You will not have decimals in a question like this. Right? There will not be decimals. You might end up, so for instance, I could change that a bit so it was over 3, but I would still not change that to a decimal. That's if the question was completely different. I would leave it as 2/3. I wouldn't change it to 0.66. Do never change things. Don't change the power of a third to the power of 0.3333. Yeah? Yes?
Could you please write another one on the board sometime just so I can practice another one like that?
Well, I'll find another one at some point and then we'll do it. There's more in your textbook. There's loads in your textbook. You can just practice those. And that's the kind of question you should be asking. Can I have more of them? Where are they? Where am I going to practice these things from? That's what you need to do now, don't you? Right? And they are in your textbook. Use your textbooks. Okay, so what I wanted to do today was the next phase of the simultaneous equations is the forming and solving simultaneous equations. All right? So could you open your book up to the problem solving section of simultaneous equations, and we'll go through a few things. No. Right, so looking at page 164, problem solving. Okay?
No.
Now, the issue with this is about, are you able to form the equations in the first place? So I think you are doing quite well with those solving things now.
Sorry, what's the title? Forming?
I'm going to do it in a minute.
What's the page?
Yeah.
Sorry.
Right? 164. So page 164. Okay? We are problem solving. So basically, though, what you need to be able to do, the main point for this is you should be able to form the equations in the first place. So if they want to make it more difficult for you, they'll give you a word problem, right? And you have to form the equations. So there's a few things we need to go through. Right? So what we'll do, let's have a look at the examples and let's just go through this. So I'm looking at example 19, right? Example 19 says two numbers have a sum of 45 and a difference of 13. It's a nice common one. So all we're going to worry about is how do we form those equations. So we've got a sum of and a difference of, very common. So what does sum of mean? To add, and a difference of? Subtract. So if we say two numbers have a sum of 45, we are saying that x plus y equals 45. Alright? Now, again, like we said before, if I just gave you that, there's no way you could guess what my two numbers are. Right? The difference of, though, if I now give you that second piece of information, would be x minus y, and it says is 13. Right? So I've got my two pieces of information. Is that easy enough to form that? Nice and simple. I'm not going to solve them now, and I'm not going to give you time to do it just yet. You can go back and do it. The answer's in the example anyway. But just to ask, what method would you use? but we've got several methods.
Elimination method.
You'd use an elimination method for this, yeah? Would you add them, subtract them? You'd add them, yeah? Could you subtract them?
Yeah.
Yeah? So if I was to subtract them, which variable would I be eliminating? X. So if I added them, I'd be eliminating y. Okay. So that's it. That's formed those equations. Let's have a look at example 20 then. So another common one is all about money. Now we did kind of do a question like this, right? So when shopping in Jamaica, 5 coconuts and 14 bananas cost $8.70. Then 8 coconuts and 9 bananas cost $9.90. Okay. It says find the cost of each coconut and each banana. So this is where we've got variables of C standing for the cost of a coconut, right? And B would be the cost of the banana. So how would I set up my two equations? So I know that I bought 5 coconuts and I bought 14 bananas, and the whole thing cost me $8.70. Now it's a bit different to what's written in the book, and I'll explain why in a second. But what's the second piece of information? Layla?
And then 8 coconuts and 9 bananas cost $9.90.
Okay. Right. Which method are we going to use? Elimination. What are we going to have to do? Not yet.
Add.
So we're going to have to multiply first, aren't we?
Multiply by.
Why? Yeah, lowest common multiple. Whichever variable you're trying to eliminate, you're trying to find the lowest common multiple. I'm very happy you used correct mathematical terms there. Very good. Right? So we find the lowest common multiple of 5C, 8C, or of 14B and 9B. Right. Now, what do we have to bear in mind with this? So, I've written 8.70. In the book, they've written 870.
What?
Why? But how can I do that?
They did.
So I can equally write, by the way, I can equally write, I'm doing a different colour so you don't confuse. 5C 14B is 870, and 8C plus 9B is 990. So why can I do? What's the difference between the two?
Because in that one they're talking in cents, and in the one that we wrote, we're talking in dollars.
Okay, so this is a value in dollars. Therefore, my C would be in dollars. So I would maybe get a 0 point something, right? B would also end up being in dollars. But this one here, I would end up in cents, yeah? So that's the number of cents. Therefore, my C value and my B value would be in cents. So it's very important that you know that, right? So that it might be, for instance, that you prefer to work with 870 rather than 8.70. But as long as you understand that the value that you get at the end for C and B would be in cents. So for instance, if it then said to you how many dollars is a banana and you ended up with it's $115, you would know that actually not, that's 115 cents, not dollars, yeah, depending on what you're working with. So you have to be able to do that. Does that make sense? So that's the important thing. It's about dealing with the currency there. Okay. So lots of ways to solve that. Then Right. The next one, example 21. Okay, let's go through it. So it says, in my pocket, I have only 5 cents and 10-cent coins. How many of each type of coin do I have if I have 24 coins altogether and their total value is 155? So they start asking you questions in a little bit more kind of different way. So how can we write our two equations then? Layla's on fire today, but let's go for someone else. I know, exactly, yeah. She's just willing to.
First, you'll use x plus y equals 24.
Okay, so you're using x and y.
Or
What do they stand for? We should state that. So you want to use x and y. What are they?
x equals 5 cent a nickel.
So the
Okay,
number.
And
So it's the number of 5-cent coins, you reckon? And it's worth stating these when you do your working out.
then
so you
y
can-
equals number of 10-cent coins, quote unquote dimes.
Okay?
So for the elimination method, it can't be say 40x and 40x, it has to be 40x and negative 40x. Elimination is what?
Remember, we either add or subtract, depending on what we've got. It doesn't have to be one or the other.
Doesn't it cancel out?
Which question are you doing?
Just randomly.
Yeah, so if I've got minus 40x and then the other one is plus 40x, if I want to eliminate that, I add those two together. If I've got plus 40x and plus 40x, I would subtract to get rid of them. If I've got minus 40x and minus 40x, I would also subtract to get rid of them. Yeah? So we had this kind of shortcut, didn't we? Whereas if the signs are different, you add. Yeah? If the signs are different on your variables, you add them. If the signs are the same, you subtract them. Okay, let's go back to this then. So we've got, I have only 5 cent, 10 cent coins. How many of each type of coin do I have? If I have 24 coins altogether, so that would be the
Sum.
So I would do x plus y has to equal 24. Alright? Hello. Okay, so we've got x plus y is 24 because there are 24 coins altogether. And then it says their total value is $1.55. So what do we write?
5x.
So every x is 5 cents. So 5x
Plus 10y
plus 10y.
equals 155 cents.
Okay. Now this one has to be 155 because the 5 is in cents. Therefore, the value at the end has to be in cents. A common mistake would be to say 5x plus 10y equals the $1.55 that they've said. That's why they did it in the question, yeah? Alright? So that is a mistake. Our other option, if we wish, would be to write 0.05x plus 0.10y equals $1.55. That's the other option, but we have to keep it. This is in cents, this is in... No, sorry, wrong way around. This one is in cents and this one is in dollars, but you can't mix the two. Yes?
Okay, so when you're talking about the value of it all, so you only need to change it between cents and dollars when x and y equals like a value of money. Like you don't need to change I
Yes.
don't know how to explain it.
Well, no, it's more like when... Do you remember in the previous one... Oh, the previous... Oh, no. The previous one... I'm just going to delete it.
The whole video?
The unknown... Not the whole video, no, just the thing, the notes. The unknown was the amount of money. Yeah, the C and the B was the cost. So you're finding the amount of money. So then you can analyse your answer and just put it in the right thing. What's different between that question and this question is that the values you're given are all the financial ones and the unknowns are the amounts. Because you notice the previous question was, I have 8 bananas. This one was, I don't know how many 5 cents I have. So that's the difference between the
So
two.
it's like an opposite.
Like save.
Okay?
Just click the
Can you
X in the
click
top
save?
corner.
Or not.
Oh no.